It's just a few hundred grams of carbon fibre and complex circuitry. But this tiny machine is set to have a big impact on disaster and military operations. The UNSW Mavstar team is at the forefront of an international race to develop a micro-aerial vehicle, or MAV, which can perform search, tracking and reconnaissance operations autonomously.
The MAV is about 30 centimetres in diameter, and it can fly indoors and outdoors and can be used to monitor different situations. If you want to monitor pipes in a building, if you want to send it in front of rescuers to look for dangerous situations, so we don't have to send the humans in.
In the Mavstar lab, the microchopper is put through its paces in a variety of scenarios. Applications for the craft range from medical assistance to military reconnaissance.
For example, in a disaster scenario, you may be able to take a small medical package into a building that's useful for somebody in there that's critically injured.
The MAV is made as small and light as possible to manoeuvre in tight spaces, but you won't find one of these at your local toy store.
The main difference between it and a remote control helicopter is that it doesn't have a tail rotor, so it is able to turn left and right just by varying the speed that the blades are turning top and bottom. We've got two speed controllers mounted on the side to control the speed of the motors. We've got a 900 megahertz XP for wireless communication with the base station. There's a gyro which detects the rate at which the MAV is turning and compensates for that. But the main difference that we have on this one is a camera which is connected to a servo actuator, and this allows us to look up and down during flight. And so we can actually see from the base station what the MAV is seeing during flight.
And just like its full-sized counterpart, flying this aircraft isn't as simple as it looks.
It's like trying to balance a marble on the top of a plate, and it just doesn't want to stay still by itself. It's always rolling in one direction, and you've got to give tiny little corrections in opposition to the direction that it's rolling.
Finessing the movement is crucial to success in international competitions where MAV research is showcased. Mavstar has successfully contested events in India and more recently the United States, where the highs and lows of competition were found to be all too literal.
We were 100% successful on one of our initial runs, so we decided that we'd go out on a limb and try this tele-operated mode. So I was not in sight of the microaerial vehicle. I was just looking at a TV and facing the opposite direction. And it went, I suppose you could say. It went straight into a pole and smashed into a lot of pieces. We've established that this thing can be flown by a pilot in direct sight. We've also established that it can be flown by a pilot not in direct sight with limited success. The next step is then going to be learning to fly this thing without any pilot intervention whatsoever.
We have had interest from a company that was looking to complete a contract to inspect power lines. These are high voltage outdoor power lines, and they wanted to investigate whether our MAV was suitable to fly along and have a look at power lines. Instead of having a crew go out there and look at every single metre, you can much more easily fly an unmanned vehicle up near the power lines and inspect them. We've had interest from other research centres who basically want to take our design and rebuild it themselves.
You're going to hang on to it for now?
Yes, we're holding on to it right now.